going to be focusing on dimensional analysis, so this one is not about the literal equations. But for our warm-up, let's review what we did in the previous lesson. A car's fuel economy, E miles per gallon, is given by the formula E equals M divided by G, where M is the number of miles driven and G is the number of gallons used. Now, go ahead, solve the formula for M, and then do part B as well. And then when you're done with both those things, unpause the video and see if you got it right. So solving the formula for M, we've got E equals M divided by G. How do I get rid of this divided by G? We'll have to multiply each side by G. So now I get E times G equals M. And then if I go to my second part, I know the fuel consumption is 30 miles per gallon and they use 9.5 gallons. So I've got 30 times 9.5 equals M, the number of miles she drove. And when you do this, you get 285 equals M. So she drove 285 miles. Now what we're going to be talking about today is dimensional analysis. And when we do this, I want to review canceling fractions. Okay, if you'd see this, this looks pretty complicated. And I only want to talk about canceling out units. Okay? Whenever units, so for example milliliters, whenever you see milliliters are connected diagonally by a multiplication sign, if you notice they are connected diagonally with this multiplication sign, whenever you have milliliters connected diagonally, they cancel out. So that means there wouldn't be any milliliters. And they don't need to be right next to each other. So as long as kilograms are in the denominator somewhere and in the numerator somewhere else, you can kind of imagine they're connected by a big diagonal of a multiplication sign. They can cancel out as well. So as long as you have one in the denominator, one in the numerator, they cancel out. So in this problem, if I were to do it, I would be left with meters over liters. The big thing I want you to get here is that when you are working with these, we want to try to simplify them before we multiply. And the way we do that is we cancel out these labels. And you can only ever cancel them out, again, when they are diagonally from each other, which means one had to be in the numerator and one had to be in the denominator. For here, with kilograms, the reason I could cancel those out was because one was in the denominator and one was in the numerator. And then on our next page, when we do dimensional analysis, basically we're trying to convert between different measurements, and maybe sometimes we go between metric and the English system, or just between different measurements within the same system. But here are a bunch of different conversion rates that you may need to use. Okay, hopefully you know some of these already, like 1 pound is 16 ounces, okay, or like 1 meter is 100 centimeters. Here's just a review of metric going on that remember. Deci means 0.1, centa means it's in the hundredths place, so this would be like 0.01. Okay, different things here. Don't worry about memorizing all these or even knowing all these because we're only going to use a select few, but this is just kind of some of the information we will be using in actually solving these problems. The big thing I want you to know though is why we can cancel out the fractions when we have something in the numerator and the denominator. That's when we can cancel out the units. And we will use that when we are actually doing this dimensional analysis.